Hello students, I am Dr.R. Professor, Department of Mechanical Engineering, RVS College of Engineering, Dindikal. So I already posted 4 videos on the subject robotics. All these videos cover the MCQs for university examinations. Today I post the 5th video on Unit 5. Implementation and robot economics. Now we'll go into the video. So Unit 5, implementation and robot economics. So here also it covers part A and part B. In this unit there are 3 parts actually, I can say. One is robot implementation, second part is robot economics, and third part is AGV. So the part A questions on all these things, as well as because in part B robot economics is having some analytical part. Robot implementation as well as AGV, we don't have much analytical part. So we are going to see part A and part B now. The first one, question 1, the resources to familiarize robotics in industries is A. Technical seminars, B. Industry trade shows, C. Magazines, D. All the above. So the first step in robot implementation is familiarization of robotics in industry. So what are the sources required to familiarize robot? So that is asked in the question. Technical seminars, industry trade shows, magazines, all the above. So the answer is D, all the above. 2. The possible areas the robots can be implemented in industry. A. Hazardous environment, B. Repetitive operation, C. Multi-shift operations, D. All of the above. So the suitable areas to be found, that is the second step in implementation. The suitable or possible areas of robots to be identified. So in this case, what are the factors to be considered? Whether A. Hazardous environment, B. Repetitive operation, C. Multi-shift operations, D. All the above. So the answer is D. All the above. The third one, the best application of the industry where the robot can be implemented is decided by A. Technical criteria, B. Economic criteria, C. Both A and B, D. Not A and B. So the next step in implementation is, so after identifying the possible areas, we have to identify one particular application or 2-3 applications of industries where robot can be implemented. The first one, we are identifying the potential areas or the possible areas. From the possible areas, we have to go for a few or 1 or 2 areas where robot is very, very essential. So that is the question. The best application of the industry where the robot can be implemented, which is decided by what factors, whether only technical criteria have to be considered, or otherwise economic criteria also to be considered, or A and B both should be considered. So here the answer is C, both A and B. So the technical criteria as well as the economic criteria must be considered for selecting a particular application in the industry. The question 4 is, the selection of robots are based on features that must be satisfied to perform the application, features highly beneficial during operation but not must, C. Must factors first and then by desirable factors. So this is the next step. After identifying the application, we have to select a robot. So how the robot has to be selected? That is the question. One is A is features that must be satisfied to perform the application. So to meet out the application, to meet out the requirement, there are some features. maybe it is degrees of freedom, a number of axes, the accuracy and repeatability. So all those things that should be decided. That should be based on that we have to select the robot. That is one case. Second case, features highly beneficial during operation but not missed. So it will improve the operation or it will do better the operation, but it is not actually a must element. So that is second one, the features. So the C, the must factors first and then by desirable factors. A is must factor, B is desirable factor. So first we have to consider the must factors and then by desirable factors. So these are all the three choices. So in robot selection, first we have to consider the must factors, because without must factors the performance is going to be very poor, or the performance is not, it can't perform the operation. So the must factors are essential, right? So that has to be selected, and then additional desirable factors have to be considered, because based on that we are bringing a rank chart in the robots. These are all the robots we can purchase, and then we have to go with the desirable factors, which robots having additional desirable factors are there. If two robots are having same must factors and one robot is having extra desirable factors, then the robot with the must factor and desirable factor has to be selected. So the answer is going to be A. Sorry, the answer is C. Must factors first and then by desirable factors. It is given as A, it is not A. Must factors first and then by desirable factors. Robot safety is concerned about A. Robot, B. Humans, C. Robot and humans. So robot safety, when the word robot safety doesn't concern only on robot, it is predominantly because the robotic laws itself, first it is giving priority to the human safety. So human safety is first. The third law only suggests the robot safety, or it emphasizes the robot safety. So whenever we are talking about robot safety, the robot safety means the safety of robot and humans, or I can say, even I can put it humans first, humans and robots. So the answer C is right, robot and humans, answer C. So question number 6, the safety features in a robot work cell. A. Physical barrier, B. Emergency stop, C. A and B, D. None. So the answer is C, both A and B, that is C. The answer C is correct. So physical barrier to prevent the entry into the robot work cell. Emergency stop, if there is any problem in the robot work cell, we can make the robot to come into a halt by means of an emergency stop, right? So both the safety features, physical barrier and emergency stop, both are safety features in a robot work cell. 7. The second level of safety monitoring system. A. Perimeter penetration detection, B. Intruder detection in the immediate vicinity of the robot, C. Intruder detection inside the work cell. So the detection, how to detect actually. So there are 3 levels in the safety monitoring system. The first level is perimeter penetration. Second level, intruder detection inside the work cell. And third level is going to be intruder detection in the immediate vicinity of the robot. So you can imagine there is a robot work cell. So that is the perimeter of the work cell, that is the first round. The second one is when any intruder comes into the work cell, that is second safety monitoring system. If he goes nearer to the robot, that is actually the third monitoring system. So in this case, The answer is C. Intruder detection in the synthesizer work cell, that is the second level of monitoring system. So remember the other two levels also. The first level or the primary level is going to be the perimeter penetration detection. Second level is intruder detection inside the work cell, that is the second level, that is the question actually. Third level is intruder detection in the immediate vicinity of the robot. Okay, right. Question number 8. Safety floor mates are used in safety monitoring. A. Level 1, B. Level 2, C. Level 3, D. Level 1 or 2. So safety floor mates are used for level 1 as well as for level 2. So the answer D is correct. So what is safety floor mates? So a mat is there. So it is actually electrically connected. So whenever there is a pressure applied on that floor mate, the circuit is going to close and it will cause a stoppage of robo or whatever the thing. So that is actually called as safety floor mate, right? Ninth one, light curtains are used in safety monitoring. A. Level 1, B. Level 2, C. Level 3, D. Level 1 or 2. So the answer is level 2. So what is this light curtains? Light curtains means there is going to be an emitting UV light. On another side it is going to be infrared light. On another side there is going to be a receiver. A number of emitters or receivers are going to be there, and because of that it forms a IV infrared light curtain. So whenever somebody breaks this curtain actually, okay, so because the emitters don't receive actually the signal, so at that time by that actually the stoppage action may be happened. Okay, that is called as light curtains. So 10. So the next is actually this is up to this. This is called as robot implementation, robot safety part we have seen. So the next one is the robot economics. Which one of the following is not investment cost? Question number 10. Which one of the following is not investment cost? A. Robot purchase cost, B. Robot installation cost, and C. Labor cost. The basic economics we know, the purchase cost and installation cost, all these things are coming under the category of investment cost. The labor cost comes under the operating cost, labor cost, materials, whatever the thing, that is coming under the operating cost. So it is not coming under investment cost. So the answer C, labor cost is not investment cost. Which one of the following is false in payback period? So there are three methods to find out the return. So for that actually we are having three methods. One is called as payback method. Then another one is EUAC method, and the another one is return on investment method. So here we are talking about the payback method. So which of the following is false in payback method? Length of time required for net accumulated cash flow equals to the initial investment. This is actually the definition of payback period. Length of time required for net accumulated cash flow, it is given as NACF, equal to the initial investment. Okay. So second one is it considers the time value of money. And C, net annual cash flow is the sum of revenue costs and total operating costs. So the first is the definition of payback period. Definitely it won't be false. And C, net annual cash flow is sum of revenue costs and total operating costs. That is also a true statement. So the false statement is it considers the time value of money, because payback period doesn't consider the time value of money. The other two methods, the EUAC method and the ROI method, they consider the time value of money. So payback method doesn't consider the time value of money. So the false statement is B. So answer is B. 12. In EUAC method, MARR stands for A. Moderate attractive rate of return, B. Minimum minimum attractive rate of return. C. Maximum attractive rate of return. MARR stands for minimum attractive rate of return. Answer is B. Question 13. In return on investment method, the project would be a better investment if calculated interest rate is A. Greater than MARR, B. Less than MARR, C. Equal to MARR. So in return on investment method or ROI method, the calculated interest rate is greater than MARR, then the project would be a better investment. So answer is A. So the next topic is automated guided vehicles. Question 14. Automated guided vehicles are driven by A. Engines, B. Hydraulic drive, C. Batteries. So automated guided vehicles are driven by batteries. So answer is C. 15. When heavy payloads carried for longer distances, which type of AGV is more suitable? A. Driverless trains, B. Pallet truck, C. Unit load carrier. So the answer is A. Driverless trains. So the pallet truck, this is for pallet type of loads actually, and C, it is still lesser actually. If the payloads are smaller in size or it is unit loads, then unit load carriers are used. So heavy payloads and for longer distances, the driverless trains are used. All these three, the driverless trains, pallet truck, unit load carrier, all these are various types of automated guided vehicles used in industry. Question number 16. When vertical movements of loads are needed to store in racks, then suitable AGV is A. Driverless trains, B. Pallet truck, C. Unit load carrier. So the answer is pallet truck. So when vertical movements of, because it is having a fork-like setup and it can store the loads in the racks as well as it can take the loads from the racks. So that is possible with the pallet trucks. So pallet trucks are the type of AGV which is used for handling vertical movements of loads. So question number 17. Parts of the AGV are guided by A. Embedded wires, B. Paint strips, C. ARB. So both embedded wires as well as paint strips both are used for guiding the AGV. So A or B is the correct answer. So C, answer is C. 18. Dead reckoning is A. Programming of AGV, B. Self-guidance of AGV, C. Safety of AGV. B. Self-guidance of AGV. So dead reckoning means the number of revolutions the wheel is going to rotate and where it has to turn and all those things, that is calculated. So that is called as self-guidance of AGV. So how many number of times the wheel is rotating. By that we can calculate the distance, because we know the size of the wheel, we can calculate the distance, and after that what is the direction it has to move. So all those things are decided by the dead reckoning technique. So this is actually a self-guidance of AGV. And 19. In RGV, the motor is powered by A. Batteries, B. Rails, C. Embedded wires. So the RGV, the board RGV, it's rail guided vehicle. So obviously the motor is powered by rails. B. Rails is the correct answer. In RGV, again there are two kinds of RGVs. One is called as monorail or the two-rail RGVs. So monorail RGVs are normally used in overhanging RGVs, and the usual rail-guided RGVs, that is we are having actually two rails. So in that actually the guided vehicles are going to move. That is in the floor. Okay. So monorails are overhanging, and two rail systems are on the floor. So that is the difference actually, the RGB. And so in the RGB, the motor is powered by the rails itself. Okay. So now part B. In part B, we are having it is mainly from the robot economics. So I will give one example in that 20. This was the question asked in previous year question paper. That I made it as a MCQ now. So suppose the total investment of the robot is estimated to be 5 lakhs. There is one shift operation of 2000 hours and one man replaced. Assuming labor rate inducing direct overheads to be ₹80 per hour. Robot running cost including maintenance cost and depreciation is ₹1 lakh, and added value of increased output is ₹1,20,000. The payback period is A 2.2 years, B 1.5 years, C 2.78 years. So this is the hint. First we have to find out the net annual cash flow. So net annual cash flow we have to find out. So net annual cash flow, how we have to calculate the net annual cash flow? Here we have to consider the overhead costs. So here first one is we are having one person is replaced or one man is replaced. The shift operation is 2000 hours and the labor rate is 80 per hour. So the overhead cost replaced is equal to 2000 into 80, that is 1,60,000 rupees. Because of the implementation of robo, this overhead cost, this is actually a positive thing actually, or otherwise it is a plus thing, added thing, because we are not going to spend that money by implementing the robo. Instead of that, it is going to be, it can be considered as a revenue. Okay. So because of the replacement of the human being or the person, we are going to save 1,60,000. So I am making it as plus, right? The increased output, because the added value of increased output is 1,20,000. That is also an addition. So it is also a plus 1,20,000. Maintenance and depreciation, actually it is expenditure. So that is 1 lakh. So that is should be considered as a minus. Maintenance, always when a product has come into the industry, we have to consider the depreciation, annual depreciation, right? So maintenance and annual depreciation cost, that is 1 lakh. So now net annual cash flow is 1,60,000. Because of the replacement of the labor, we are going to save, that is a plus. 1,20,000, that is increased output, that is also a plus. But we have to spend 1 lakh rupees on maintenance, and we have to calculate the depreciation also. So that is going to be minus 1 lakhs. So totally the net annual cash flow is 2,80,000 minus 1 lakh, that is equal to 1,80,000, right? That is the thing. So 160 plus 120, this is 280 minus 1, that is 180. So what is payback period N? N is equal to IC by NACF. What is IC by? IC is initial cost divided by net annual cash flow. So how much period, in what period we are going to take the initial cost, that is actually called as N. N is equal to initial cost by NACF. The initial cost is given as 5 lakh divided by 1.8 lakhs or 1,80,000. That is equal to 2.78 years. So within 2.75 years, 78 years, we are going to get back the money invested. Okay. So in case the robot life is 5 years, another 2.22 years it is going to give you the profit. So the initial investment is it is received by the company within 2.78 years. If the life of the robot is 5 years, for example, I am saying it's 5 years, another 2.22 years it is going to give you the same 1.6 plus 1.2. This 2.8 is going to be its this 1.8. This is going to be the benefit to the company. Okay. So another 2.22 years, the same 1.8 net annual cash flow is not going to change. That is going to be a profit to the company. Okay. So there are a similar type of questions may be asked actually. So payback period, you remember this formula, N is equal to IC by NACF, the initial cost by net annual cash flow. I hope this video is useful to you. Thank you for listening.